find the connected particles on the plane. Whoop. What do you want to say? You tell me. Four? On which page? Is that all you want to see? Guess so. Yeah. Are you sure?
Oh.
Is it all?
No, we did this week because you mentioned.
We did two worksheets. Motion on a plane
That's the first one.
and connected particles.
It's that one.
We did two, yes.
And that's the next one.
So,
Yeah, connected particles, I think it's fine.
well, let's see what everyone thinks. Yeah, so,
Maybe the last one.
yeah.
Yeah, so
Are you sure? So this one's okay?
That's fine.
Sure, basically the same thing.
You say it's the degree is between, is it?
Yeah.
And this one is this?
Yeah.
So it's this degree is then
Mhm.
the bigger.
Mhm. Yep, it's the same, yeah. Do you want me to do number 4 on both?
Sure.
4
Yes.
and 4. Yeah. So I'll do 4.
Wasn't there one control?
Yeah, I'll do 4 on the connected particles. So first I'll do number 4. Okay. A wire is 26 meters.
You can't do that.
Oh, that's a problem. Okay. The wire is 26 meters, and these A and B are 24 meters apart. So that means that's 12 and that's 12, if it's 24, yeah? And the wire is 26, so that means here and here would be 13 and 13, yeah. And you hang a weight here, which is M. Okay, the first part is to calculate theta, which is here. So that's okay, because you can say, yeah, sine theta 12 over 13. So theta is, yeah, it'll be what they asked for, won't it? You use your calculator. Okay, now he goes on to say that the tension here is 600 newtons, and the tension here is the same, 600 newtons. And you also know this is mg here, and you also know that this here is also theta. Now, this t, I can break it up. Okay. Louise, this one here,
Yeah.
is this cos or sine theta?
Cos.
I tricked you. It's sine theta. And the reason is the theta is actually up the top today, So this one is the cos, because the theta is here, not here. Can you see my little pen? The theta is not here,
Oh, yeah.
it's up here. So it's actually the opposite today. So this one up here is 600 cos theta. Okay.
Sorry, not very clear.
Not clear?
Yeah, not clear.
So here's theta.
Yeah.
So I'm saying that this red piece here, that's 600 cos theta. I wonder if I can make this. I don't know how clear I can
But
make
the
it.
opposite is look
Yeah, go on, yeah.
in the red, like the blue line.
Yeah, let's see now. This is actually the opposite, believe it or not, because if you look here, if I draw my triangle here,
Yeah.
okay, let me put in a different color, green. If I draw my triangle here, this one here is the opposite, which is the same as this. And actually this one here is the adjacent. But remember, whichever side touches the angle, that's the side that's the cos.
Yeah, I love that one.
Yeah. And the side that's opposite here, that's the sine, which is actually this one here. I think it's not clear because I wrote it up here. I should really write it like here, 600 cos for this one.
No, I love it.
It's okay? Alright, so that's 600 cos theta. Actually, this question isn't turning out to be so difficult because I can just say 600 cos 67.4 must equal mg.
No.
No?
2 times 2.
Oh, times 2, thank you. Of course times 2 because there's 2 of them, yeah. There's 600 sine this way and 600 cos this way. There's 2. So what do you get for the m here?
47.
47 kg?
Yeah.
Yeah. That would be a section A question in the exam. I think the next one now looks kind of long with the truck on the last page. On the last page. Where's Saeed? I saw him earlier today. Do you know where he went?
Is it in shopping?
Oh yes, I saw him,
Yeah.
and you saw him. So where is he now? Do you know?
No.
No, don't know. He didn't say he had to go anywhere, did he?
No.
No, okay. Okay. Right. So in the next one, number 4. Whoops. Is my battery charging up? Yeah. A truck is made with a large cylindrical tank. Ah, okay. So I'll try my very best to draw this. What you have is a truck. It's a truck. Yes, I'll see how well I can draw a truck. Not bad. Yeah, okay, it's a truck. It's a truck. So the reason I drew it like this is because in the question they tell you that the truck has this large cylinder tank. Okay. What?
I didn't know.
I don't know what happened for this.
This is okay truck, isn't it? It's very what?
He's very happy.
Oh, okay, great. Look.
Yeah. They're not disagreeing that the trailer.
Oh yeah, and look, I'll even put the exhaust pipe at the back. Alright. Okay, so this truck, large cylindrical tank of inner diameter 2.5 and length 5.2, and the mass of the lorry when empty is 8 tons, and 1 ton is 1,000 kilograms. So the total mass of the lorry when filled with oil of that density is 31 tons. Okay. So, if I just look at the tank part, okay, what they're saying about the tank is that it's a cylinder, and the length here is 5.2 meters, and the diameter is 2.5 meters. Okay. Did I give you the formulas for the volume of a cylinder?
No, but...
You know it already. But anyways, yeah, if I go down, so if I look at this cylinder, its height is 5.2, and its radius, yeah, it's 1.25, because it's half of this number. And the volume is pi r squared h. Now, some people will remember this from middle school, some people will not. You said you remembered this formula for the volume of a cylinder. Okay, so when you put in these numbers, what do you get? 25.5. Yeah. Okay. Now, what's the formula for density? Mass over volume. So then the mass is the density multiplied the volume. Now they give you the density. What do they say it is? It's 900. And you got the volume, 25.5. So together, what does that make? 22,000? So 23,000 nearly.
23 tons.
23 tons, yeah. 23,000 kilograms. Okay, so then the total mass equals, it looks a bit different though. I got 8 plus 23.
Yeah.
Which,
31.
oh no, that's fine, yeah, 31,000 kilograms. In other words, 31 tons. Yeah. So in this question they said the truck, when it doesn't have any cargo, is 8 tons. And then the cargo is filled with oil in the tank. And when it's full of oil, the oil is 23 tons. So in total, it's 31 tons. Okay. So when the truck is empty, it's only 8, and when the truck is full of oil, it's 31. Okay. That's the A part, is it?
Yeah.
Yeah, okay, so now the B part. The loaded lorry is travelling along a level horizontal road at a constant speed of 15 meters per second. Calculate the kinetic energy. Okay, so kinetic energy is a half mv squared. That's a half 31,000, and the speed is 15 squared. So that's 225. So what's that? 15500 times 225. I've run out of brain power. What's this equal to?
3.49
megajoules. So that's just a straightforward calculation of kinetic energy. Nothing strange here. Now the next part. If wind resistance and friction gives a total force of 3,200, find the work being done per second. Now, this is the, sorry, can I go down? Yeah. What they're saying in the question is that the friction force, which is called the drag, that is 3,200 newtons. But Newton's first law, which you all know, says that if the speed is constant, and the speed is constant here, speed is constant at 15 meters per second. Therefore, by Newton's first law, there must be the force exactly the same driving it of 3,200. And this is the drive force. And this is the force that the engine is doing. So we know what the F is. So the question is, what's the work done per second? Per second. So in 1 second, how far does the car move? Yeah, 15 meters in 1 second, because its speed is 15 meters per second. So the work per second is force multiplied distance per second. So that's 3,200 multiplied 15. So what's that? What is it? 48 kilojoules. Yeah.
Kilowatt,
Well, yeah, its work per second is 48 kilojoules. So you could, if you want, say the power is 48. I should really say per second here. Yeah, I really should. Yeah, so in other words, the power is 48 watts, if you want to put it like that. Kilo, yes, I just lost 1,000 kilowatts. Yeah. Okay. I think the last part is the tricky part. Can I do the last part? The last part, I said part C, I said you might not be able to do it for these questions, so I'll do part C for this question now. So part C. So the truck is now on a hill, and the angle here is 3.05 degrees, and it's moving up the hill, and it's still moving at 15 meters per second. How much work is being done per second? You'll have to use MGH for this one. And we have to find the H first, that's right, yeah. So that's why I'm going to draw a triangle here. Yeah, this is 15 meters, and this is the H, and this is 3.05. But anyways, we know that this piece here is 15 cos or sine? Cos. Yes, this is cos. And then the one that we want is 15 sine. So on your calculator, what's 15 sine? What is it? Oh, sorry, 15 sine 3.05 is, yeah? 0.8? It's really small then, yeah? Well, 80 centimeters. No, that's okay. 0.8 meters. So that means in 1 second it gains 0.8 meters. In 1 second. So that means it's gaining potential energy. Yeah. This potential energy it gains it from the engine. I mean, it's the engine that's doing the work. So the gain in potential energy is how much work is being done, which is, as we know, mgh. And we know the M, what was it, 31,000, wasn't it? G, 9.81, and H, 0.8. So what's the work done per second now?
242,713.
No, give it to me in a nice kind of...
Okay, 243 kilowatts.
Kilowatts.
kilojoules per second.
Yeah, 243 kilojoules per second, or in other words, the power of the engine is 243 watts.
Kilowatts.
Again with the thousands, kilowatts, yeah. Now, let me think. Okay. I think for this topic now, what do you think? Difficult or easy? What's your opinion?
Can't be a lot harder.
What's that, Louise? Middle? Yeah.
Can't be a lot harder than distance.
What's been the easiest topic for you? Well, tell me. What do you think? What stands in your mind as the easy topic?
Everyone agrees.
No, you can have different opinions.
Dynamics is easy.
Which one do you think, Ugo?
Linear motion.
Linear motion?
Yeah,
Just the formulas.
UVATS?
yeah, that's right.
Yeah. What's been the most difficult? Moments were difficult, weren't they? The turning force? Newton's three laws. Yes. Yes, number 3. You did your presentation on number 3, yeah?
You see all of them, or just the third?
Presentation.
Yeah?
I did the first 2 of them.
Yeah, but I mean, you're all working on the presentation together.
Yes.
Yeah. So I mean, it's not like, yeah. Huh?
Different. Sorry. Because the guy to do the law and just to search the information about the music.
Oh, so you don't read what they write?
It's just.
That's not too much, not too much.
Not too much.
Eat it out. This is what we're doing. Take it in.
Yeah. You see, because we have the exam. Did you get your timetable for the exams?
Oh, yeah.
No. And the maths is on Tuesday, and I think the physics will be on Friday.
Okay.
I think
Monday.
I think it's Monday.
I wonder if
I'll do
English.
chemistry first.
English, I don't
Yeah,
know.
I'll have to get out of the way.
Chemistry is the toughest one, is it? Too much English?
No,
Too
it's
much
just
fun.
too much.
Too much what?
Just don't like it.
Yeah, I just don't like it, okay, yeah. But what's the difficult part in chemistry? Just don't like it.
Yeah, I think the main thing about chemistry is that like if you leave something out, you just get 0 marks for like the whole question.
Well, that's true for anything.
No, but like even if you have like 90% of the answer, you still get 0 if you get that 10%. That's the one bad thing about chemistry. That's what she told us.
It's all or nothing, is that what you're saying? Okay.
Just the idea like I don't really like that.
What about now the physics, the test on Friday? Do you feel prepared, or do you need to revise? Because I have some new topics I need to do with you when we come back, so I won't be able to give any time for revision. I have I still have, I think 3 more topics to do with you. 3 in this section. Remember we said that the course is mechanics. This is what we're doing now. This is part 1 of the course, and then there's 6 parts in total. And we split it in 2 semesters, yeah? Remember this? So we're nearly finished this mechanics and Newton and all of this. There's only 3 topics left. Simple harmonic motion, circular motion, and the pendulum. Yeah, so that's why they're grouped together at the end. And then the second thing we do is the electricity. And then, waves is what we do as the third topic. Yeah. Now, the bad thing for you is this topic at the start of the course, this is the biggest topic because we're still doing it and we will still do it after the holiday.
How about experiment?
Some experiments will be here in semester 2. And the experiments will be 2 on this topic, 1 on this topic, and 1 on this topic. So your experiments, you'll have 2 experiments from mechanics, 1 on electricity and 1 on waves. Yeah?
What are you going to say this semester?
Huh?
Is that
Second semester will be materials, fields, and atoms.
What's the field?
Yeah, fields are things like magnets,
electric?
stuff like this. Yeah. Materials would be things like heat, plastic, all this type of stuff. And atoms, of course, from chemistry. Yeah. So I can't really give time for revision after the break. Because I still have 3 more topics to do, and then you have the test. Yeah? All of mechanics. Yeah.
I'm feeling similar with some homework and circular.
Yeah, everything. So yes, your test after the holiday is on mechanics. Everything was done. So there's a lot to study. No, because it's enough to do this, because the questions will look like these worksheets.
How many questions?
I don't know, I don't want to give you too many because it's just a 1 hour test.
I got it out of it.
Yeah? Well, let's see. Maximum.
Question.
6 would be a lot to do in an hour.
Yeah.
6 maximum. Maybe 4 or 5. Something like this.
You just take
4 is good. I know that makes it more complicated for me to correct then. Yeah.
So I just to prepare the last time you give us the sheet between
The sheets are okay. Yeah. Here. Now.